Hello, my name is David Larson, and I'm here in my office in downtown Floyd, right in the heart of Appalachia, the Blue Ridge Mountains. Floyd is a small town of about 430 people, so we really enjoy living in this rural area of the Blue Ridge. Today I wanted to talk to you a little bit about a phone conversation I had with a colleague of mine, Dr. Jonathan Titus. John and I worked together in the Blacksburg Group back in the late 70s and early 80s, along with several other people involved in the group. And today I wanted to talk about this little slide rule that John designed. And we'll look into a little detail, but this is a wonderful microcomputer memorabilia artifact from the 70s. This is a programming aid for the 8080 microprocessor chip. And people that programmed in machine language or assembly language could use this and have all the codes at their fingertips very quickly by sliding the slide rule in and out. On the back side, John had some other charts here for ASCII code, American Standard Code for Information Interchange, and some other good information. But if you look at the front of the card, you'll see the name Ticon. Well, we called our company Ticon for several years, and then later on we changed the name to the Blacksburg Group, and we did most of our work as the name of the Blacksburg Group. Well, just to look a little bit closer at this card, and the reason I want to do this is, remember, I'm representing this as really microcomputer memorabilia, and also a very clever design that my colleague John Titus did. But this is a programmer's tool. If you were programming the 8080 microprocessor, this represents all the machine code instructions that allow you to manipulate data within the 8080 and do math and logic functions. And we call it a slide rule because, if you see down here, we can slide this back and forth, and that allows us to pick up all the different functions with some of these instructions. Let's look at one little instruction which might make sense. Move whatever data is in register A to register L. There are registers within the microprocessor, and so this MOV is a move. This is called a mnemonic. There are programs called assemblers that can take these mnemonics and convert them back to the machine code level. We cannot, that's right at the base level. We're manipulating bits right in the computer, bit by bit. So we take the mnemonic, assembler converts that back to the machine code. But this card represents all the possible instructions for the 8080. And if you look at the back side, John also included some additional good information. Here's a chart that represents the ASCII code, American Standard Code for Information Interchange. This is a 7-bit code that allows us to encode or represent in 7 binary bits all the alphabet, control functions, punctuation, various other control functions. That's called the ASCII code. It's been around for many years, been around since the late 60s. And some other functions he has down here, an octal to binary chart. Again, octal is a shorthand way of writing 3 binary bits. So this is a shorthand notation. And this is what we see right here. When we were looking at this MOV and this number over here, this 175, that's an octal representation of binary bits. And this is the mnemonic representation of that, the move A to L, move A to L. And of course your assembler program can convert that into the binary equivalent. Really great little programming aid, fits right in your pocket. Great design by John. Of course you see our bugs here. The bugs are actually used earlier than this. This card was on the market around 1976 or so. And we actually used the bugs earlier than that. We'll talk about that some in some of our blogs as well. So great little microcomputer memorabilia. And if you're still programming the 8080 microprocessor, you can latch onto one of these. It's a really nice, compact way of carrying the entire instruction set in your shirt pocket with this little slide rule.